Review number 1, numbers 14 through 17. Start with number 14. Adam is definitely going to ask Eve to go out with him. He's deciding whether to ask Eve to go with him to winter formal or to prom. If he asks her to go with him to winter formal, he has a 30% chance she will say yes. If he asks her to go with him to prom, he has a 40% chance she will say yes. If the actual probability that he asks Eve to go to winter formal and she says yes is 24%, what is the probability that he chooses winter formal instead of prom? Now, the way I showed this is with a tree diagram. So we have either winter formal, I'm going to use a W for winter formal, P for prom. So this probability, these probabilities that he actually chooses to ask for winter formal or chooses prom, we don't know yet. But we do know the chance that she will say yes, because she's either going to say yes or no. Yes or no. Now, the probability, again, the actual probability that you ask Eve to go to winter formal and she says yes is 24%. So after this is 0.24. Now, if we go back to this part of the problem, if he asks her to go with him to winter formal, he has a 30% chance she will say yes. That means winter formal yes is 0.3. So this winter formal percentage times 0.3 should give us 0.24. To find this, we're dividing. So we're going to take in the calculator 0.24. We're going to divide by that percentage right before it, 0.3, and I get 0.8. That means there's 0.8. It says, what is the probability that he chooses winter formal instead of prom? 0.8 or 80% is that probability. Part B, what is the probability that he chooses to ask her to prom? So instead of winter formal, there's prom. Now, initially, when he makes his first decision, it's just one of these two things. It's either winter formal or prom. So since now we know there's an 80% chance of winter formal, since these are the only two options, they have to add up to 100%. So I'm going to take 100 and I'm going to subtract the 80, I get 20%. There's a 20% chance of him asking her to prom. Now it says, what is the total or overall probability that Eve will say yes to going to prom with Adam? Now it just says prom. It doesn't say going to either of these events. So we know from the tree diagram, we just found that there's a 0.2 or 20% chance of him actually asking her to prom. From the problem, there's a 40% chance she says yes if he asks her to prom. So to get this probability of saying yes, of him actually asking and her actually saying yes, we have to take that 0.2 of him asking, the 0.4 chance of her saying yes, and multiply those two. 0.2 times 0.4 is 0.08, which means there's an 8% chance that she says yes for prom. Number 15, the two triangles below are similar to each other. Excuse me, find the missing length. Now it looks like it's kind of hard to see. If you had tracing paper, you could probably trace it and rotate, but what you need to do is visually match this triangle on this one by rotating. This 3 is going to end up matching up with the blank side. So right away, I'm going to just put 3 over x. And then you have to match up 4 and 6 with 10 and 15. Now I only need to match up one of those pairs. But if this rotates around, that 4 is going to end up top with the 10. The 6 is going to end up on the bottom with the 15. So I can either go 4 over 10 or I can go 6 over 15, and it shouldn't matter. I should get the same thing either way. Now, since I was able to match up those, now I'm just cross multiplying. X times 4 is 4x. 3 times 10 is 30. And then I'm dividing 30 by 4, and that becomes 7.5. So my value for x is 7.5. Number 16, quadrilateral ABCD is a square. Which of the following statements is true? Choose either that apply. CA is congruent to DA. CA is a diagonal, DA is a side length, which is not true. This is like the hypotenuse of a right triangle. CA will always be longer than one of the side lengths, so that's not true. AC, there's AC, the diagonal again, equals 2 times BE, which is true because each of these are equal. So 2 times BE would be like this whole length, which is the same as this whole length. So that is true. CE equals 1/2 of BD. It's basically the same as this one, just kind of reversed, which is true. CE is half of this diagonal BD. And the last one, AB is congruent to AD. AB and AD are both sides of the square. That is also true. So B, C, and D are all true. Number 17, the last one. Samantha has been learning to play some new card games and is curious about the probabilities of being dealt different cards from a standard 52 card deck. Help her figure out the probabilities listed below if, in each case, she is dealt a single card from a complete deck. Now, before we go through A, B, C, and D and find these probabilities, a reminder that you have for the deck of cards, you have hearts, which are red, diamonds, which are red, clubs, I'll go ahead and write these out, heart, diamond, club, which is black, and then spade, which is also black. Now for all these cards, you have an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, and then you have your face cards, because they literally have faces on them, jacks, queens, and kings. Part A says, find the probability of being dealt a queen. Now there are, again, out of the deck, 52 total cards. For the queens, you have a queen of hearts, a queen of diamonds, a queen of clubs, and a queen of spades. So in the deck, you have 4 queens total. 4 divided by 52 gives us 0.077, which is 7.7% for your probability for part A. Part B, what is the probability of being dealt a red ace? There are, of the aces in the deck, there are 4 aces total, but remember the hearts and the diamonds are the only ones that are red. So there's an ace of hearts, an ace of diamonds. There's 2 out of 52 cards that are red aces. 2 divided by 52 gives us 0.038. And remember that after that 8, just remember about the rounding. When we did this 0.077, I rounded up 0.76. I cut it off here. That 9 was over 5, so that made me round that up to 7. Here I cut it off after 3.038. That 4 is less than 5, which means the 8 stayed as it was. It didn't go up to 9. So our probability is 3.8% for part B. Excuse me. State the probability for part C of being dealt a 2 or a 3. Now, as soon as it says or, that means we have to do first the probability of the 2, then the probability of the 3, minus the probability of a 2 and a 3. Now, there are 4 2s in the deck, so that's 4 out of 52. There are 4 3s in the deck, that's 4 out of 52, minus. Now, when it says probability of 2 and 3, there's not. Most people just say, oh, there's 8 because there's 2 and 3. But remember, this is actually literally saying that the card has both a number 3 and a number 2 actually written on the card, which never happens. So there is no overlap with these. So our probability is going to be 8 out of 52. And then I take my trusty calculator, 8 divided by 52, and I get 0.153, cut it off at the 3. The 8 makes it go up, so it becomes 0.154, which is 15.4% for part C. The very last one, D. Determine the probability of being dealt a king or a diamond. So a king, again, face cards, there's a king of hearts, diamonds, clubs, spades. That's 4 out of the 52 that work for king. Plus, and again, since it's the or probability, I'm setting up like this one previous to it. The diamonds, there are, for the diamonds, ace all the way up through kings. If I count up those total, there's 13 total cards. Minus Now I have to do the overlap. I have to do a card that's both king and diamond. So if you're setting up the equations, probability, I did probability of king first, plus probability of diamond, minus probability of king and diamond. Now there is a card in the deck that is both a king and a diamond, the king of diamonds. And the second one I've checked off here, that is your diamond card, which happens to be a king also. So there is 1 out of 52 that are both king and diamond. So when I add these and subtract the 1, I get 16 out of 52. So I take my 16 divided by 52, and I get 0.307, cut it off. The 6 makes it goes up, make it go up. 0.308, which means my probability is 30.8% for part D on number 17.